All right, why don't we get started? I know that we have a pretty packed agenda today, even though we also have a 2-hour meeting slot. So welcome to DTN Working Group for IETF 116. I am here in person. Rick Taylor, our co-chair, has joined us remotely. But let's continue. For those for whom this is your first IETF meeting, please note well some of the things that are pointed out here. Let me call out one or two in particular. You agree to follow our IETF processes and policies while you are here. Anything that you may talk about that is covered by patents or patent applications must be disclosed. Also, as we get into sort of this next slide for our meeting tips, the thing in red here is that the session is being recorded. When the IETF is done, all of these meetings will be available and posted to YouTube, and be aware of that. In order to participate in person, please make sure that you are signed in to MeetEcho. You can also use the MeetEcho Lite client on your phone, but you can find that link from the data tracker agenda. The full MeetEcho icon is the camera icon. The MeetEcho Lite is the small cell phone icon. Even if you are in person, if you want to join the queue to ask a question or make a comment, please join the queue on the MeetEcho first so that we can see that on our chair screen. The way that you join the queue is by clicking on the small raised hand icon within MeetEcho. When you are finished and come back from the queue, please also remember to click and leave the queue virtually. If you are remote or in person, please keep your video and audio off unless you are asking a question or presenting. And we do require, as IETF requires, that everyone in the room please be masked. If you are not masked, please do so now. And please only remove your mask if you are asking a question. Otherwise, if we go on to the specific agenda, we are all here and it's the second day, so hopefully we're familiar with these links. We're going to spend just a few more minutes going over some of the admin topics, and then we're going to dive right into our presentations. We have several of them. We're going to try and get through all of them, and we will be moderating our time to make sure that we stay on time, and we do have roughly 10 minutes of open mic time at the end. Before we begin, are there any concerns or requests relating to this schedule at this time? Nope. Okay, moving on. Lastly, we do need minutes taken. There is a shared notepad. Please join with Adam to make sure that we have the best notes that we can. And Adam, would you serve as the Jabber scribe? Thank you very much. All right, with that, Rick, is there anything else you'd like to add?
No, all good from my end. Thank you very much.
So the very first agenda topic is just some awareness around two different working group documents that we are finalizing now, and I just want to make sure that the working group that we have some attention brought to it. The first one that has just been adopted are the COSI security contexts for BPSec. For those of you that are unaware, BPSec is the Bundle Protocol Security set of standards, RFC 9172. And that requires the use of security contexts for exchanging and interpreting the cryptographic material that's carried by BPSec. There is a set of default security contexts published as RFC 9173. This would be the second set of security contexts, and we have adopted it based on work done by Brian Sipos. If you are interested and knowledgeable in these topics, in particular COSI and PKI certificates, we ask that you give this some review, and we ask that you post to the mailing list. We would like to put this into regular review and working group last call over the course of this year. The second document that we are looking at now are an update to administrative record types, or to create an administrative record types registry for BPv7. This is a somewhat small document that clarifies that BPv7 agent is intended to use a particular subregistry for its administrative record types, and that it makes a code point reservation for private or experimental use. A request has been made for working group last call on this For those that have either read it and do not believe we should do a working group last call on this, or for those that have a concern about doing a working group last call on this, are there any concerns about taking this to working group last call at this time? If so, please let us know now. And Mark is going to join the queue.
Mark, I'm sorry, I didn't started the Meet Echo, so I was not able to. When we started DTN working group, DTN-RG had a lot of code points that were not registered in IANA. So I wrote the first document to registers all those code points to IANA, right? But in fact, we should not, as a working group, do documents and RFCs just to register code points in IANA. We should do this inside the working group documents, the protocol definitions. So I'm saying this should be our last document that is just about registering IANA code points in IANA registries. Everything else should be done within the protocol documents.
Heard and understood. Since I know that Brian Sipos is the person asking for a call on this, and he is unable to make it to this meeting, what I would ask is that could you take that and post it to the mailing list just to make sure that he would have a chance to respond?
Yeah, it's fine. I'm just saying that should be our last one.
Fair enough. It has been claimed that this document is holding up something in another working group, so we've been asked to prioritize. Rick.
Very quickly, replying to Mark, yes, I completely agree. The reality is this is the last of the documents to catch up with the omissions that were made in previous documents to get the registries right. It's something personally I'm very keen on making sure we get those into the documents, but IANA do require a document to cover it, which is why we have to have this. But yeah, I couldn't agree more.
All right. Thank you very much. So please, again, if you have opinions on those two documents, make sure that they are represented in the mailing list. Otherwise, let's get on to our first major topic for the day, which is the IPN URI schema update. Rick, take it away.
Thank you very much. Ed, I'm probably going to ask you to click next. It's probably easiest. So hello, I'm Rick Taylor. I'm one of the two co-authors on this document. We've talked about it a fair few times before, and we think we have taken on board all your comments. So next slide, please. So substantive changes since the last version. Fundamentally, we have taken on board a lot of the comments based on the discussion around this document, and we have rewritten a lot of it to remove what we had before, which I would consider rationale text. So when I first brought this document and with my co-author Ed, we had a lot of, this is why we are bringing this document, this is why we are proposing this change text. Now that the working group is familiar with it and it is a working group document, we have removed a lot of that rationale text and replaced it with what we call specification text. So the document now reads as a spec, which is what one would expect in a standard. So that is if you do a diff between this version and the previous version, you'll see a lot of the text has changed, but the vast majority of that is about the tone of the document. The other major thing we have done is to split the document into two clear parts. Not sections isn't quite the right word because there's like 8 sections, but the first part of the document deals with the IPN URI scheme. So as should be familiar to people, DTN addresses things in terms of URIs, and we are specifically in this document talking about an update to the IPN URI scheme. So the first half of this document almost is just focused on that URI scheme, meaning the second half talks about how one encodes these updated IPN scheme URIs for BPv7 to be used as endpoint identifiers. And having done that work, I don't know about Ed, but I personally feel it really clarifies the document into 2 parts so that you can understand what we're talking about with IPN URIs and then some of the issues we're addressing in terms of encoding that. And of course, all the other comments we received since IETF116. However, if you made comment, I do recommend you review what we've written, just to make sure that we have taken on board your comments to your satisfaction. So that's obviously just a plea for constant review, please. Next slide, please. So, quick summary. What we state in this document is that all IPN scheme URIs are now of the form authority number dot node number dot service number, where the authority number is a numeric identifier of 32 bits length of the authority that allocated the subsequent node number. The subsequent node number is a common number, 32 bits in length, allocated to IPN URI resources co-located on the same node. Now, these are logical constructs. Remember, URIs talk about resource identifiers. It's all about resources. And this is the first time we'll introduce the word node, and I'll come back to it throughout the rest of the presentation. And it's been the hardest part of getting this document right is dancing around this word node. And in this case, when we're talking about URI schemes, we're talking about a logical construct, nothing physical, and we're really trying to dodge any bundle protocol DTN connotations. We're just saying everything. Every resource that is named with IPN that is co-located on some logical construct called a node shares a node number. The third part, as before, service number. So this is some way of discriminating between well-known or private use types of service. And it's important to consider those as types because different nodes can all have a .2 service. It is of type whatever .2 is. I don't believe it's actually registered or in use anywhere. But if someone's using a .2 or a .58 million, great, that's fine. They can all agree we'll all use 58 million to be this type of service. Next slide, please. So everyone is immediately going to say, oh, but you've added these authority numbers. What was wrong with what we were doing before? Well, nothing really. The purpose of the numbering authorities is to give a discriminator to allow a better allocation of those node numbers. But the existing IANA registry that has existed up until this point and will continue to be used is given the name the default numbering authority and is given the value 0. And when composing IPN URIs that use the default numbering authority, i.e. 0 as the first component, that 0 is omitted. So if you have an IPN which is in effect 0.x.y, it is written syntactically in the text format as x.y. So all existing implementations that expect x.y can continue to work on x.y, and the numbering authority is automatically assumed as 0, and therefore the default numbering authority has allocated that number. When we say the default numbering authority, we mean there is the number has been the X, the node number has been taken from the existing IANA registry. So we are forward porting the existing IANA registry that was used for CBHE, bundle protocol version 6 encoding, and so it's inherited through and brought forwards and updated and renamed to make sure it is absolutely explicit that this is the set of allocations that have been handed out under the auspices of IANA for numbers allocated by the numbering authority 0, also known as the default numbering authority. And in reality, what that means is we have reserved some well-known node numbers, and we have maintained the existing allocations that exist in that registry at the moment. So node number 0 is the null endpoint. If you're unsure what that is, go and check the references in this document, which point to RFC 9171, BPv7. The null endpoint is basically nowhere. So node number 0 is nowhere, has uses within bundle protocol version 7. Node number 1, we have introduced in this document to mean local node. You could think of the equivalent of local host, but we decided to avoid overloading that word. So a 1 dot address means it's on the same node. So service 2, if it wanted to talk to service 1 and didn't need to look up its own address all the time, could say from 1.2 to 1.1, and it would just get routed by the bundle processing within the node itself and would never leave the box. That means fundamentally that node number 1 local node identifiers are non-routable. So there is strict rules in the document to say if you have a 1 dot address, you must not let it leave your box because it is a relative local address only. The other clarification which came out of the previous conversations and on the mailing list was the range 2 to 2 to the 14 are declared as private use. So that means anyone can use them, and they are free for all space. So effectively white space, unallocated spectrum, which means unless you know that you are the only unique user within your administrative domain for these private use numbers, you must assume that they will clash. So great to use for your experiments, great to use for your private network that isn't going to intercommunicate with anyone else unless there's some translation or some firewalling or something protecting you at the edge of your administrative domain. Happy to use them within that, but do not assume uniqueness outside of that scope. And that's in line with current deployments. Beyond 2 to the 14, all of the extra allocation comes out of the existing registry. So if you already have an allocation in the CBHE registry, that will continue. You won't lose your registry. And yep, as somebody pointed out in the latest review comments, when I took the snapshot out of the IANA registry, I took it about 3-4 months ago, and I think some more registrations have been made, so it needs to be aligned. But rest assured, we will be aligning that right up until the point of publication. Next slide, please. By the way, if anyone has any points, please jump to the mic while they go past. I've got quite a few slides that cover quite a few parts here, so very happy to take interruptions. So, having introduced the default numbering authority, this opens the door to registered number authorities, i.e. non-zero numbering authorities. And the purpose of this is to allow organizations, be they space organizations or terrestrial organizations or whoever wants to use IPN URIs, not talking about bundle protocol, just URIs here, they can now say, I want to grab a block of node numbers that I want to allocate according to my rules and my policies, and I want to ensure that they're unique when used in a heterogeneous bundle processing, in a heterogeneous manner with other IPN URIs. And in order to do that, we introduce a new registry for these numbering authorities, where they're given a identifier by IANA from the 0 to the 32-bit range, and that is that first number in the triple that makes up your IPN URI. What is new in this revision of the document is we have allowed we've allowed organizations to ask for a range of authority numbers. So I was originally quite keen on having numbering authorities and sub-numbering authorities and having some sort of complex, almost endless series of dots that you could have because mathematically it was interesting. A lot of people turned around at that point and went, that's utter madness when it comes to processing and parsing and having limitless strings. It's not a great idea. So we went back round to the other end of the spectrum and said, okay, there was only one number which identifies your numbering authority, but it was felt that we had lost some ability to have a range allocated to a supra organization wherein they could subdivide those allocations within their own hierarchy. And so an external observer could say, oh, anything in that range, any node number allocated by a numbering authority in this range, I can treat according to some similarity rule. So using a bundle protocol example, CCSDS could ask for a range and could then hand out one of the numbering authority numbers of that range to each of the member states that takes part in CCSDS or member sub-organizations. So an external observer who would receive a BPv7 bundle could look at the source or the destination any of the EIDs and say, oh, I see, that has come from the CCSDS supra organization, whether it be NASA or ESA or whoever, and can make some semantic decision based on the fact that it comes from this range. How this gets adopted and how readily this gets used, we'll find out, but the capability is there for very little expense. So the rules around that are got to be a power of 2, and it's got to start with all low bit 0. So it has real similarities to CIDR IP address assignment, but of course these aren't addresses. This is a common prefix to the usual 2 to the 32 bits of node number that people can actually use to identify nodes. Adam, you're in the queue. Go for it.
Hey, Rick, Adam with his secretary hat off. So I like how this is working, but to use your SDS example, they get allocated a range in an IANA in the registry. It says this range is allocated to CCSDS. Would there be a mechanism that CCSDS could go back and say, hey, we took this one number and gave it to a sub-authority, and we'd like to put it here to say that's where it went? Is that a mechanism we want to use or have, or do we want to ignore that?
So I think you've asked 2 questions there, if I understand it. I think you've asked, can I retrospectively extend my range, or can I retrospectively hand off the allocation I have to somebody else? Is that what you're saying?
Kind of, but it's more just a metadata thing that CCSDS goes back and says, I want to just mark somewhere publicly that this is the sub.
Okay, I understand. So CCSDS, let's use them as an example here, but it could be, Uber org X, decides to grab, say, 16, a range of 16 numbering authorities, and they hand out 1, 2, 3, 4, 5 with the bin mask. It's as far as IANA, who own this registry, are concerned, they have been given 16. Being a large organization, it's the onus is on them to say, actually, we hand out this within this range, and we have handed them out to the following people. And so we're almost delegating the responsibility of that to somebody else. That's not to say that, and I don't know how popular these are going to be and how big these are going to be, because you get a lot of numbers with these. It may be the case that CCSDS says, IANA, can I have this range of 16? And by the way, if you want to fill in your registry to say the first is this, the second is this, the third is this, we would have no objection. But at that point, it means if CCSDS wants to change that registration, they would have to renegotiate with IANA. And we might get pushback from IANA to say there's a lot of churn on this registry, what's going on? I don't have the answer, but the way we wrote it was, by grabbing a range, you are taking control of the delegation of that range that you have taken. Does that answer your question?
Yeah, that answers my question. It was just a thinking as an implementer. If I could see, oh yeah, this is a CCSDS, but if I wanted to see if I could go deeper and there was a public resource to just go and look it up, why wouldn't I, right? It's like saying,
yeah.
So, but thank you.
Yeah, it's an administrivia issue, really, but it's about the whole idea behind this process is to reduce the load on IANA registry for handing out every single IPN URI ever, and we'll see how it goes. Eric, go ahead.
Thank you. Yep. Sorry. I guess 3 things. I'm sure I'll forget something. I don't know if it's of use now. It can be added later, but consider whether you want a documentation example /31 of authorities. So you have.
Yep. So I have a final slide about sort of to-dos and debatable things, and that's definitely one of them. So yeah, no, good question.
The second thing is, I think in the IANA, is it table 3 with the initial values, does not contain like a range column. I think if they're going to be allocated in ranges, it should have a range, and you might also include like the ranges in a slider format, if that works. And then lastly,
Sorry, quick point on that. We were quite wary about doing that slash notation because I think it had such echoes of this is an IP address, and we're not talking about. It's not part. If it was part of the node number, I could see that argument being valid. But we're really saying these are such high order bits that introducing. I just felt weird about putting a slash notation, but we can
yeah,
take
it feels
that.
like we're starting with class A, B, C, D again.
Yeah, but we're 64. We're 32 bits up already. So you have to keep that in your mind.
And this is only the IPN scheme. There's DTN schemes, which is
Oh yeah. This is just IPN. Yeah.
But at least there should be some, it should say 1-to-1 or 1-to-16 or whatever it is for when for.
I completely agree on that. Yeah.
And then the last thing was, I guess related to the slash notation was whether or not you see the slash notation becoming something that needs to be denoted in a string form, and maybe we don't need to worry about that at this point. If you want to avoid the suggestion that we're reinventing classful space.
So I read an interesting article a while ago where someone's saying the worst part of Cider was when they introduced the slash notation. So suddenly it became very difficult to parse whether something was a subnet mask or an IP address. So I would be tempted to say when someone is talking about this is a filter that applies to a range, it should almost have a different syntax from this is an IPN URI. I'll take it to the list.
So I was just going to jump in the interest of time, let's take that to the mailing list because I think there's a lot to say there.
So I'm just going to catch up on one thing I'm watching go past on the chat, which is I made the comment about local node, the null node, and the private ranges. Those numbers are only reserved for the zero numbering authority, for the default numbering authority. If your numbering authority number 71, you can use any number you want between 0 and 2 to the 32 minus 1, however you wish to do it. The end. The local node is only 0.1.x, just for clarity. Okay, next slide, please. I don't want two local nodes is the short answer. So part 2 of the document is kind of part 2 of where I got to at the moment, which is about the CBOR encoding of IPN URIs for use of Bundle Protocol version 7. So I hope you've all read BPv7, but within BPv7, there is a section to say when you are encoding URIs for endpoint IDs, then there is a registrar. There is a registry which determines how you specify which scheme you are using, and IPN has the value 2, I think, off the top of my head. Someone correct me if I'm wrong. It might be 3. I can't remember. But if you say I am type 2, then there is a specific encoding for IPN URIs. What we are doing is maintaining the existing encoding and adding a second encoding. So the first encoding is the 2-element scheme. That is exactly the same as written in Bundle Protocol in 9171. But what we have done is we have re-expressed it to map the semantics back to our initial formulation of an IPN URI, so in terms of authority number, node number, and service number. So really, it's a bit of wordsmithing. The identical on the wire representation really makes no difference, but it's just to make sure with consistency it maps through correctly. 2-element scheme, stored as a CBOR array of 2 elements, and I'll come into that a bit more. 3-element scheme, you store as a CBOR array of 3 elements. The reason for this is that if you have a non-zero authority number, you will get a better, a more concise encoding. If you have a 0 authority number, you don't need the 3-element scheme. You can continue to use the 2-element scheme. It is more concise. Okay, and because the length of the array when encoded in CBOR is the first octet you parse as you walk down the stream, the encoding schemes are blatantly different when you are writing your parser. And if you are a pre-existing parser, you will spot a 3-element scheme and say, I don't understand this, and react appropriately. So that means the 3-element scheme is incompatible with existing deployments. So that needs to be a consideration when someone is trying to interoperate with a pre-existing deployment that doesn't understand this updated document. But if they do know that, then they can use the two-element scheme and it is entirely interoperable. Next slide, please. So to repeat on the two-element encoding, what we have said is on the wire representation is exactly the same, because in RFC 9171, the node number and the service number are both considered 64-bit unsigned integers. If you remember back to the start of this and reading the latest version of the draft, we have said an authority number is 32-bit and a node number is 32-bit, so that we can do a bit shift, concatenate the two together, and put the authority number in the high 32 bits, the node number in the low 32 bits. And this is compatible with the existing allocations from the CBHE registry. We haven't allocated more than 32-bit numbers. And this also allows you to encode your authority numbers not quite as bit efficiently as the three-element encoding, but it works. They're distinguishable, they are unique, and existing implementations, having talked to various people with existing implementations, will handle this without a code change, which is quite important for things which are just about to deploy. Okay, second element remains the service number. If you're using the default numbering authority, it's 0. You don't need three-element encoding. You can continue to use the two-element encoding and you get a nice, short, concise encoding. Identical to 9171. Next slide, please. Three-element encoding, I kind of summarized it before. You've got three elements: authority number, node number, service number, just as we defined for the IPN URI. You encode it as a three-item array, nice and short and sweet. Next slide, please. So this is what we have updated. Having put out, it's quite late here. Having put out the 01 update, we got some really positive feedback on the list, which was fantastic. And these are the things we absolutely have to change, and I haven't had time to do. So yeah, we've got some typos, we've got some incorrect references. Eric, as you say, the table 3 is out of date with text higher up in the document. Table 5 is missing allocations. We are going to rework section 4.2, which talks about node IDs and EIDs. That's a bit of a sort of unpicking. We'll wordsmith that and push that around the mailing list a couple of times just to work out how far we want to go into that. I'm running out of time, but I'll keep it short. Authority number ranges, it's the low bits. That was a pure typo. We're going to reserve an authority number range, probably way up at the top end for future use. It's good practice. Ran Atkinson suggested it, and we should have seen that one. He's spot on. Yeah, and the IONA content. So last slide is actually the most important one as ever. These are the discussion points where I'm not sure Ed and I quite feel we have enough rough consensus to work out where the steps are, and we're looking to the working group for a bit more clarity. Authority number allocation policy. Currently, we've got a first come, first serve for anything over 4,096. Is this too low? Should we have first come, first served, sort of 2 to the 16, 2 to the 32, remembering that there is a step function with CBOR encoding? Beyond 2 to the 16, you're into 4-byte encoding. There's no 3.5 byte or anything like that. There's a debate there. Or should somebody said it should just be expert review for the whole thing? Maybe, you know, or is that too onerous on experts for when somebody says, I just want a bit of, you know, I don't know. But these are authority numbers. So perhaps, you know, are you actually a legitimate organization? Have you got a PO box? Do you have an address? Do you have a picture? That kind of checks. Perhaps that should be expert review, open to suggestions. There's no experimentation allocation. So if you're writing an implementation and you want to check that it works with the 3-element encoding, what value do you use for, this isn't a real one, but it's great for my test, you know, example.com equivalent. Service number allocation policy. We have currently specified that specification is required for anything lower than 4,096. This was literally me looking at port allocations for TCP and UDP and saying, we've survived quite long with that. Let's keep going. But of course, we've got a 2 to the 64 address space. Perhaps we could be greedier and say, do you know what, the good numbers down at the bottom end, because they have concise CBOR encoding, more of those should require specification? Could we do something where the 1 byte encodings are 50% specification, 50% free for all, 2 bytes likewise? Should the private use service numbers be pushed up into the what I call the unattractive to encode range? You must use 8 octets to record your number, or is that penalizing people who don't want to publish their funky protocols they're using in-house for something that isn't of relevance outside of their internal processes? And the third and final comment was one that I know Ed and I have discussed several times, and I know has been discussed a bit more widely. Now that we talk about numbering authority number, node number, we have lost that useful phrase for this is the ID of the node, because the ID of the node is now made of the concatenation of the authority number and the node number, and we don't have a useful term. I think Scott Burley said I'd like to call it a node numeral. My worry at that point was we then had a node ID, a node numeral, and a node number, and a slightly soft definition of a node, and it all got a bit node, and I worried we'd lost people at that point. But I'm really interested in what people think about this. I'm a bit of a English language pedant, it being my first language. If other people have a better idea of how to make it less pedantic British English and more usual specification language, let's talk about it and get it right. I'll shut up and cough now. Go ahead.
We do have 2 people in the queue, so we will take a little bit of time for questions because this is important, but we will try and get back on track soon after. So Eric?
I'll try to be quick. I would call into question whether or not you need to have a service number allocation policy. Unlike TCP and UDP port numbers where they were not part of the IP address destination, like this is a thing for the resolution layer. We don't necessarily need to have well-known service numbers anymore, because unless you're going to like not use the service number or not specify the service number as part of an endpoint, it's always going to be in the endpoint. So it doesn't have to be reserved, I think.
I'm not sure that's how it was originally envisaged. I went back through the history of this stuff, and BPv6 had a ping well-known service number, so you knew you could send a certain bundle, the certain crafted bundle to .2 on a node, and it would send you back a pong. Same as having a health check. If I send something to the well-known health service, I know I will get a status to say I am alive, rather than nothing. I can see that being the kind of well-known service, and that's where those numbers came from.
All right. Yeah, so maybe there is a use case for a small number of them, and then I would just propose like fully qualified node number, as like FQDN for 3.
Next is Mark.
No, are you done with the slides or?
What's
That's
your
the last
question, Mark?
slide.
That's the
Okay.
last slide. Yeah, I'm done. Sorry, that was, yeah.
Thank you. So I'm kind of neutral to this proposal. My comment is not about the proposal itself, but the authority number thing, allocation. To my knowledge, IANA doesn't talk to organizations. The only one registry I know is the PEN, the private enterprise number, which is essentially an automated bot, right? Nobody is actually behind it. It just generates numbers for you. On the contrary, IPv4, IPv6 AS numbers are actually only allocated to RR. Therefore, then they do downstream allocations, right? So my first point is we may want to have a discussion with IANA if they want to receive all kinds of requests from, organizations, authorities of any kind, whatever the, if the policy is expert review, whatever, right? Whatever is the final thing.
Mm-hmm.
We may want to make sure that IANA is okay with that. Second, back to your question or comment was, if I don't know who would be the expert, say it's Rick, are you going to verify that, I'm an organization and, all that thing? Or are you asking Ayana to do that or something? So again, I'm neutral to the proposal, but I just want to raise some interesting questions that may happen, not far away.
So thank you. And again, in the interest of time, I think this is, again, more discussion for the mailing list. There is a section in the draft that talks about guidance to designated experts, but it's something that needs to be looked at. There was one last slide, and what I simply wanted to say here
Forgot that one.
was that please, for the things that we have talked about here, make sure that your comments are represented on the mailing list. Rick and I will be putting together a updated draft that addresses the comments that have been made so far. Our goal here is to put this into working group last call relatively shortly. And obviously we would not put something into working group last call or if it had open items. So if you do have things that you've seen today, make sure that any concerns are posted to the mailing list as soon as possible. Right.
Right. Thank you very much.
Rick, thank you. Our next presenter is Sarah Heiner, who's going to be talking about the DTN management architecture.
Let's see. Can you all hear me? All right. Great. So I'm going to be speaking to the updates that have been made to the DTN management architecture, or DTNMA draft, since we last spoke at IETF 115. Next slide. So the document is currently at version 5. We've reflected the feedback that we got after last session, which was very helpful, so thank you. And I'm going to take the rest of this time to give a high-level overview of the DTNMA in the hopes that it convinces you to give this document one final very close read to give us any additional feedback that you have so that we can start moving towards working group last call. Next slide, please. So to start in on that overview, the DTNMA is a management approach for challenged networking environments. And I've laid out some of the key features that get us to that point. So starting with open loop controls, since we are in a challenged networking environment, we can't rely on timely round-trip communication, and we can't support a request response architecture. Instead, we're using open loop control. Second, we're using autonomy to acknowledge the fact that the managed and managing device are often not able to communicate. So we need that managed device itself to be able to self-manage, in this case, apply policy and use an autonomy engine to provide deterministic behavior across devices. And third, we need a compressible model. We need compact encodings so that we can implement the DTNMA not only on resource-constrained devices, but also create the small message sizes that we need when we're operating over intermittent or low-rate links. Next slide, please. So digging further into those decisions made to support network management in a challenged environment, I've put the reference model up on this slide to talk through a couple of those features. So in the brief moments of connectivity that we do have between the managed and managing device, we take advantage of that to pre-share data definitions. So data and models are shared so that the manager and agent, also the managed and managing device, are able to agree on what information needs to be modeled, what actions can be taken when certain state information is observed. And then second, getting back into the idea of autonomy, the agents themselves need to be able to manage themselves, since a manager can't be expected to always be in the loop. We use a local autonomy engine to do that. So policy statements are provided by a manager that give the cues for the agent to then take and apply different actions when different state information is observed. And then finally, we're taking the route of command-based management. So because we're in this challenged environment, we aren't using bulk updates and large data stores. Instead, we provide the managing device with a command and control interface, which allows the exchange of information like policy to configure that autonomy engine. Next slide, please. So getting into that actual autonomy model, you can see at the top of this figure the flow of information of the DTNMA manager providing policy statements to the DTNMA agent, which is maintaining a local rule database. That policy is being translated into rules that identify state information of interest and the action or actions that the agent should take if that state information is observed. And the agent can take several different actions. It might be updating that local rule database, its runtime data store. It might be instructing a managed application to execute a control, which would influence its behavior, or it might generate a report to inform the manager of the event that's occurred. Next slide. So I'm going to try to be careful with time, but run through some of the desirable design properties that we've incorporated in the DTNMA, just in acknowledgement of this challenged environment and the fact that this management approach needs to be able to handle these challenges as they scale within the network. So next slide. So first property is dynamic architectures. We acknowledge that there is going to be a dynamic network topology. So we need a dynamic architecture to take advantage of that rather than be hindered by it. And I've put on the slide here for emphasis that the DTNMA is designed to run in every environment that bundle protocol can be used, but there isn't an underlying transport protocol requirement. So we're avoiding limiting assumptions like a static network topology or prescribing a specific protocol stack for this solution. Next slide. Second is hierarchically modeling our information. So if we are using ADMs, application data models, within the DTNMA, we want to be able to hierarchically relate them so that we are avoiding repetition and then being able to reuse those data models as is appropriate. And these models are also cohesive, so they are to manage a single application or protocol. And that gives us the compressibility that we need, concise encoding, as well as pattern matching and parameterization in support of autonomy. Next slide. We also need to support push mechanisms rather than pull mechanisms for the exchange of information. And we use local autonomy to determine what information and when it should be pushed from an agent to a manager. Next slide. As I touched on earlier, we need efficient data encodings. Part of that is provided by the data model design, and that allows us to minimize message size. Next slide. We also need universal absolute data identification so that we can manipulate individual data elements. So I've added an extract from the BPv7 BPA ADM as an example of the way that we're structuring this information so that the agent and manager can perform that information exchange, agree on data definitions, and then follow the same absolute data identification so that the agreed upon information is being monitored or manipulated. And this allows us to avoid some of the approaches that other network management approaches would take that we can't handle in a challenged networking environment or might cause undefined behavior. So the examples that I've put up here are associative lookups or synchronizing on state information, both familiar approaches, but approaches that aren't effective in a challenged networking environment, particularly because of the delays and disruptions that we might encounter. Next slide. We also support runtime data definitions. So this is creating essentially a new piece of data from existing data. So that's support for items like data fusion and sampling. Next slide. And then finally, we've touched on autonomy a couple times, but just to drive that point home, the standalone operation and management of the agent is important due to those times of disconnection between the manager and the agent. And this provides the deterministic, predictable behavior of that agent, even when those devices are disconnected that we need. Next slide. And I believe that this is my final one. So just an acknowledgement of the updates that we've made to the use cases, just as a way of showing how the DTNMA can be applied to different challenge network scenarios, giving a more concrete idea of how this might be used. So with that, if there are questions.
Thank you.
Oh, go ahead. I believe we have Sally in the queue.
Thank you very much for the presentation, Sauli Kiviranta. I have just a comment about this notion of when you have entities that you're trying to remotely control and you have no certainty about their availability. So that might, what I like very much what I see is that you intend to have shared models that all the entities are talking about the same things, but approaching those models to be changing state through controls, you might end up with extremely difficult scaling problem. So that, and especially to validate that those control instructions have been implemented correctly. So what might be interesting to little bit look at is that can you more communicate towards not trying to give a action where to go, but set the end state, reference end state for the entity. So just a comment about that. We might discuss later about it.
Oh, definitely. It would be great to take this to the mailing list as well, and we can discuss. I can make it much clearer, the data model and the way that we're supporting controls and limiting, I'll say limiting the actions that we're taking in response to state information.
I would just jump in. I know we have two more people in the queue. If we could make the points very quickly, and then we can take further discussion to the mailing list. But Stuart, you're next.
Thanks, Sarah. Question about your statement that the autonomy must be deterministic. Do you mean fully deterministic, or do you mean bounded, as in like the ASTM standard 3269, standard practice for methods to safely bound behavior of aircraft systems containing complex functions using runtime assurance?
And we have all memorized that, Stuart. Yeah, yes, of course.
So the point that I meant to emphasize in saying deterministic behavior as well as predictable behavior is that the goal of this autonomy engine is to ensure that when the manager and agent are not able to be communicating, we can still know what state to expect from the applications that are being managed by that agent. By specifying and being careful about the actions that can be taken as a result of the change in state information, we know where the applications are ending up. We know the state that's.
Understood. So I guess that's a question as far as the resolution of knowing the state. Do you need to know the state down to the individual bit, or do you need to know that the state lies within some bounded space?
So I will say that that is a good mailing list discussion. And one more, Mark?
Thank you.
Marc Blanchet, maybe it's not appropriate for your presentation, but you mentioned Yang models. Are you having Yang models, or that?
Yeah, so that's something that I just passed right over because in the interest of time. But the point that I wanted to make on that slide is that we're emphasizing that this combination of new features is what's motivating in this management approach, but we don't have to, and we are intentionally avoiding reinventing anything that's already providing those features. So yes, we have the ADM to provide that data model, but Yang is a viable data modeling language to be using in this case as well.
And also just to jump in, the architecture document shouldn't be in that level of detail, but there have been internet drafts for Yang models of ADMs. Do we hear volunteering to continue that work?
Well, I was looking for a Yang model for a BP node. That's actually where I come from. So,
All right, thank you. Our next presenter is also named Sarah Heiner, and we'll be going over the asynchronous resource identifier updates, ARIs.
Yeah, sorry, can't get rid of me. So I am presenting on behalf of Brian Sipos, so going over the updates that he's made to the ARI draft. Next slide. So to introduce this, the ARI is a part of the DTN management architecture ecosystem. And it's the mechanism that we use to identify and invoke objects within the ADM, the application data model. And the ARI draft has been out for a couple years. That's resulted in several implementations. And in implementing that draft, there's been identification of some ambiguities, as well as some inefficiencies in that syntax that Brian's updates are focused on fixing. So to the second to last point on this slide, these are changes that are in work and definitely looking for feedback in terms of what's been changed here and the lengthy list of to-dos at the end for next steps. And then just a point that the changes that have been made to this document impact the ARI encodings, but they're not changing the concepts behind the AMM, asynchronous management model objects, or the ADM itself. Next slide. So kind of a humorous poke at motivation, but the driving goal here, to paraphrase from Albert Einstein, is that everything should be made as simple as possible, but not simpler. So in other words, we're trying to make this ARI syntax as simple as we can, simple, usable, easy to encode. But at the same time, the ARI is a powerful tool within this ecosystem. So we can't oversimplify to get rid of important capabilities like parameterization or object nesting that we need for management within a challenged environment. Next slide. So there are a few issues that are addressed by the updates to this document. First being that the binary encodings of an ARI were close but not quite CBOR. So that led to some complexities that caused people to have to implement custom handling for special cases and different corner cases that we are looking to eliminate. There were redundancies in both the binary and text encodings of the ARI. So for example, the object type was present twice in some of the object reference ARIs. The text encoding also had some ambiguities, specifically the URI path components were not well specified. And then there were also some ARI types that could either be eliminated because they're not being sent over the wire and we don't need the ability to encode them, or they could be replaced by another object type without the loss of any capability. There's an example in here. Next slide. So moving towards simplification, the changes that were made to the ARI structure itself was first the explicit categorization of ARIs. So an ARI is either a literal or object reference. There's no overlap in those sets. Second, an ARI in its binary encoding is now a CBOR item. So we're able to use CDDL to define that schema. And we can also use COTS validation tools to both validate and generate that CBOR. The text encoding is a context-free grammar. It's no longer dependent on the ADM itself, but is modeled after the ADM structure. So the example in the middle here shows that an ARI is composed of the name of the ADM that defines it, and then the object type and name as well. And then there are several points on here for the restriction and simplification of naming. So the namespace items have been reduced. We're restricting names further to use the URI segment NZ ABNF pattern. And we've also removed the scheme prefix from nested ARIs. Next slide. So there are some really bunched up examples on this slide. I apologize for that formatting, but the emphasis here is that this update allows us to represent new encoded forms. So you'd see that in the byte string that's shown there. And then the example at the bottom is to just show now using this context-free grammar, we don't need to consult the ADM to determine the parameter type. Next slide. So there was also a goal to simplify typing overall. So this started with the separation of literal types from object reference types, which we discussed, but then moved further to separate the AMP-specific literal types from the encoded types, which brings us closer to mirroring CBOR. And then there were some object types that could be removed because they're never present in an ARI. They may be referenced by an ARI, but they're not present within the actual ARI. So they don't need to be encoded and be sent over the wire. Next slide. And this is to drive that point home, showing the object types and the primitive types and the updates to those code points and the removal of compound types, which are the objects that we don't have to support and send over the wire. Next slide. On here, you'll see that the binary ARI encoding is now real CBOR. So again, this allows us to use already existing tools for validation, which makes that implementation much easier. And it also gives us smaller encodings in several cases when we compare to the original draft. And I believe that there's an example of that on the next slide. So untyped literals and object references are now always giving us shorter encodings with this update. Typed literals can result in a longer encoding. There is an example, which is again not super clear in this slide, but the unsigned integer example is a slightly longer encoding, but in general, these binary encodings are now more efficient because we're using true CBOR. Next slide. So in summary, the changes that have been made here are the separation of the literal and object type ARIs. We've simplified the text encoding using that context-free grammar, moving away from that dependency on the ADM. The binary encoding is now pure CBOR, and we have a CDDL schema that we can use with that. And the restrictions that we've added on naming have made the text encodings easier to use as well. Next slide. So the last 3 slides are laying out related issues as well as next steps in the direction that we want to take this work in. So I would encourage people who are interested in this to take a closer look and pull out some of the open issues that you'd like to discuss and bring that to the mailing list. Just trying to be conscious of time here. So with that, I'll wrap up and take any questions that you have, as well as encourage you to speak with Brian on this.
All right, excellent, and thank you very much. Particularly nice to see the reduced encodings around the control execution. Okay, so now.
Sorry, Ed, very late to the queue. Can I just jump in with a quick question?
Of course.
Sarah, thank you. Really interesting. I must admit, I haven't looked at the ARI spec for a good couple of months, so I'm a little bit rusty here. But the ARI syntax, if I remember correctly, is about directly not just directly, about referencing members of the instantiations of ADM models and also parameterizing that reference. Am I correct in that thinking?
Yes, that's correct, Rick.
Yes. So it's. I wonder whether there's parallel work here that could be looked at in terms of. And I've been having this side conversation with Carsten Borman about this. It's almost CBOR path, if you could consider that to be a CBOR equivalent of JSON path, which, and we can all argue whether JSON path is fit for purpose or not, but it's a way of encoding in CBOR a way to reference another thing with sufficient parameterization. This is partially me with my chair hat on, trying to nudge Carsten into giving us some advice in this area and to cast his eye over it. And I know Brian can't answer, have you looked at some of the sort of JSON path legacy and XPath, I suppose, predating that when looking at this?
So I can't answer on Brian's behalf, but I will just say that since ARIs need to support, like you said, parameterization, but also object reference, definitely looking at any existing approach for that would be important here.
I suggest at the end of the meeting you walk to the back of the room, and on the right-hand side is Carsten Borman, who knows everything CBOR. I think he's on the right behind you. I can't quite see anymore. Thank you.
All right, thank you very much, Rick. All right, Mark, email over bundle protocol.
Konnichiwa. First thing first, I'm wearing this t-shirt that says BP is not IP. So copyright is from Jorge Amodio, who suggested that, and I took his idea and made a t-shirt. So yeah, I can. They are on sale for paying my trip here, so it's $2,000 each. So, okay, I'm working on, up in the stack and running applications over IP. So let's start with email. The idea here is to send email to, from, and between planetary bodies. Bundle protocol used between planetary bodies. Obviously, this is a space, kind of examples, but applies to. Assumption is that there's an IP network on planetary bodies, and that's the current plan of various space agencies architecture document. So instead of inventing a new email protocol native to BP, then just reuse internet email, but encapsulate into BP. So both sides will use regular internet email software and protocols on your, whatever device. Next slide. So that's an example. One side on the left, one side on the right uses standard, for example, maybe on Earth, use standard email protocols, SMTP, IMAP, POP, whatever you want, GMAP. Connects to a SMTP server with identified in the DNS as the MX record for the other guy there, mars.nasa.gov, for example. Receive the email, knows that it needs to go through here, the next SMTP server, and then passes on the BP gateway, bundle the email in the bundle, encapsulate the email in the bundle, then send the bundle up to the other one, decapsulate, and then use standard IP email protocol, SMTP, IMAP, POP, whatever, on the other side. Clear? Next slide. So why are we doing this? Because SMTP is chatty, many back and forth. So for those who know SMTP, hello, and then, features, exchange and stuff, mail from, recipient to, and, so it's really chatty. So it makes no sense to actually encapsulate every exchange in a separate bundle because it takes forever. So instead, you put the whole mail, including headers, in a single bundle. 00, the first version of the draft encapsulate using RFC 5322. Comments from Stuart for many, RFC 5322 doesn't include the envelope. You need instead include the envelope in the envelope, and then you should use batch SMTP, which is RFC 2443. Therefore, 01 encapsulate 2443. Next slide. Considerations. If email is big, for example, including media or else, you rely on the bundle fragmentation below to take care of this. Not doing the SMTP chat, which is kind of a negotiation, means that both ends need to know each other feature set, right? So there is no negotiation. Well, the extensions, XMTP extensions and feature set are pretty stable. And for space, you won't change your SMTP server in space every week. So I don't think it's a big thing. Well, and if in an event it actually doesn't work, then you just get an error message back. Request, Eric, you were saying we don't need a service number assignment. Well, that's an example I wanted, so that we would request the draft request service number assignment for email SMTP over BP. Note to IANA is 25 would be cool to get, but generated case is a spacecraft is a BP node, and therefore you could, for example, run the mail server and the BP node all together with the mail client on the same host, and you would receive email on the spacecraft. Yeah, operations of DNS and IP networks and all. So this is all out of scope of this document, but it's been worked on somewhere else. Next slide. So looking for working group adoption. I'm working right now on an implementation using POSFix and UD3TN. Why use UD3TN? It's just because they have an application agent protocol which is simple and quick for implementation and prototyping. When done, we'll post so people can try and join. If you plan to implement, please send me a note and we'll arrange some interrupt testing. And that's it for me.
All right, we have one question so far. Stephen's in the queue.
Oh. Former DTNRG chair.
Thanks, Stephen Farrell. That's Also, somebody who implemented email over previous generation of the bundle protocol. This could be done. I think it's probably a bad idea.
Thank you very much.
So when we did this kind of thing, we found it was much more useful to look at synchronizing message stores over the bundle protocol.
That's another
not
way.
trying to layer SMTP over the bundle protocol. And there's a bunch of reasons for that. I think and we could argue them, but perhaps not right now.
Yes, I want to argue about them.
So, but we can get into that, sure. Secondly, I think, did you say you wanted to publish the MX as an SMTP over bundle protocol entity, or
No. So,
so let me.
yeah. Let's.
If you do this, I'm wondering where the spam goes.
Okay. Let's discuss offline. It's just not a big deal, but I can tell you. You can enjoy it.
But again, I think if you're layering SMTP over the bundle protocol, then spam is a thing you're going to have to consider a lot, because you're going to get a lot of spam.
Oh, well, yeah, we can.
But I think my higher level point is, I think, yeah, sure, I have no objection if you or somebody wants to do this. I'm not trying to stop you, but I think it would be wiser to kind of try and sit back and think of when people are using mail in this kind of context, what would be the sensible thing that they might want to layer over the bundle protocol? And my pitch would be that it's maybe more likely to be message store synchronization.
I agree. That's another way of doing. I should probably wrote some notes about it, but I think it's that this way is actually a way which is completely independent on whatever implementation. It's really strict SMTP. No, if you do synchronization, you need know the format, right? You need to do rsync or whatever, and then mail store format and stuff. So it's getting into more implementation details. SMTP is really encapsulating SMTP is really very standard protocol, whatever the implementation is on each side. You don't have to bother about that.
I don't know if the chairs want to have this discussion now, or if you want to kick it
So
off.
I was just sort of leaning in. There were sort of two or three things quickly with chair hat on. One is the question before the working group is what are we asking for? Are we asking for working group adoption of a way to carry SMTP over BP, or are we asking for a way to exchange emails over DTNs? And those are different questions. And so what we have right now is a proposal for doing it one way, but perhaps what we should have before this is some statement on what are the problems and concerns related to exchanging emails in a DTN at all, which may go into spam, which may go into MIME types and SMIME and just a whole bunch of other things that we will probably get into. So that's a statement, not a question. But the request, in the interest of time, is that we take that question to the mailing list, because before we do working group adoption on this draft, we should understand whether this is the draft we want to be writing.
Sure, I think that's fair. And I mean, I'm not asking that somebody writes an RFC that describes the problem statement or something, but I mean, just I think it would be wise to do some analysis as to what would the working group be better off spending effort on. And just to pick one example of the benefits that we saw from message store synchronization was that if you have if you have the same message store content in two places and you've read the mail here, when you get there, you'd like to see the mail showing up as read and not unread.
No.
So there's a bunch of issues about usability that might be interesting if as Ed suggests, what you want to do is think about email and DTNs as opposed to SMTP and the bundle protocol.
And a limitation of MeetEcho is that there's not a queue for people in the queue, but there's now a question for you, which is, do you have writings about your implementation of email over BP that would be published or otherwise accessible?
Yeah, I think I sent something to the list earlier. I mean, it's a kind of a crappy publication, but I think it was there, and I could possibly even resurrect some Subversion repository or something that had a bunch of things. But yeah, I think I've sent that to the list already.
Okay, all right. Thank you. But before we go to the next presentation, any additional comments? Okay.
So I did 4 minutes, 6 minutes altogether. So it's
We have
saving time.
it's much appreciated. So let me reset the clock.
So I don't see Stefan anymore, but he's there. I agree, different ways. I think mine is better, but we should argue on the mailing list. So another example of applications over BP, HTTP. Next slide. Given that most use application frameworks, applications in general right nowadays are using HTTP, then the idea here, the motivation is to reuse all those tools in that, JSON, REST API and stuff, as you probably all know. The next comment is a bit of a, a statement that I may not should say, but the space application developer is just now a regular internet application developer with some best practices if we run HTTP over BP. That's a far-reaching statement, but so HTTP queries and responses are from, to, and between plenary bodies. HTTP has by itself no notion of time. There are some headers that have notion of times, but HTTP itself doesn't. Bundle protocol is used between plenary bodies, IP networks, similar case that I described previous presentation. And so instead of inventing a new application layer protocol and application and framework over BP, then reuse HTTP. So both sides are using regular HTTP software and protocols, as we know. Next slide. So this is an example. HTTP client, HTTP server, bundle protocol in between, HTTP proxy, or name the one you want. A little shim that actually implements the draft BP agent on both sides. That's it. Next slide. So you encapsulate the whole request and response in a single bundle. If the content is too large, use bundle fragmentation. Both endpoints have to keep track of each connection being encapsulated and decapsulated. Therefore, a random ID, UUID, is added in the front of the HTTP payload by the requester, the one who starts the communication. Since HTTP payloads may be continuous, like video streaming over HTTP, both endpoints have to know when it is done or more is expected. Therefore, a counter is added in the front of the HTTP payload. Value of 0 means there's no more. This actually method of encapsulation was implemented in our C++ BPv6 implementation a while ago and was able to do streaming over DTN without any issue. Next slide. Considerations. While one could fetch an HTML page in this scenario, and it works, the typical HTML page would contain a lot of objects and that are referenced, and therefore further fetch what would generating many requests. So essentially that could work, but it's far from a good design, not the right time to make beautiful web pages. But for applications using REST API, JSON, and HTTP semantics, this is all fine. So don't do fancy HTML pages in this environment. Negotiations such as, for example, URL redirection or else can be used and will work, but again, not recommended because you're still getting, back and forth. Requesting again a BP service number assignment for this HTTP encapsulation. Here, careful considerations on time-related headers, for example, cache control and all those things that related to time. Would need to be carefully, considered. It's not in the current draft. It's actually in my local copy for consideration about those HTTP headers. Generated case is similar to email, which is a spacecraft is a BP node, an HTTP server, and a the BP node are all on the same host and the server respond. And operations of all this is out of scope. Next slide. Comments received. I actually had the draft reviewed by Mark Nottingham. Looks fine. For those who know, Mark is Mr. HTTP in my world. So I was like, oh, okay, cool, thanks. Brian Sippos, very good comments. Multiple HTTP versions are actually use RFC 9292. I did browse it. Looks good. We'll do in next rev unless I find something bad, but good idea. Brian proposed to use a connection ID and sequence number to be encoded in CBOR. I disagree. Text in this context will not add so much to payload, and it's way more easier to debug. Moreover, if you refer to my my diagram, the shim can be implemented by the HTTP proxy or by the bundle agent, whatever, but if or something different. But in all cases, if it's done, it may not, the shim may not have a CBOR library of any kind. So why are we, using CBOR for just a small shim here for no good addition? So multiplexing, yes, it's covered, but it's not, talked in the draft. We'll do in next rev. And unsolicited response for example, preemptive caching. So HTTP 2 and 3 already has this, and it's probably need more text in the draft for describing this. Next slide. I think that's the last one. So similar, looking for working group adoption. I'm working on an implementation using Nginx and UD3TN. We're happy to post when done. If you want to implement it, please send me a note. That's it.
And to the looking for more comments bullet, we have 2 people in the queue. So the first one is Rick.
Thank you for this, Mark. I suppose I've got 2 comments actually. My first comment, I think, applies to both this and the SMTP draft, which is, I think there's more power to be achieved here, rather than just taking the HTTP protocol units or the SMTP protocol units and sticking them in a bundle because the delay doesn't matter because of the way those protocols are built. And destructuring the logical parts that make up those protocols and using the multi-block metadata block capabilities that we have in bundle protocol in order to store those logical components. So you could imagine having, for an HTTP request, you could have a bundle which has a standard primary block, would have an extension block, which would be the HTTP headers, and the payload you could then include directly into the payload block. Following on from that, chunked encoding in HTTP 1.1 is probably worth looking at. That would solve your sequence numbering piece. Other thing off the top of my head, of course, is that unsolicited responses for HTTP 2 and HTTP 3 solves the problem of, I want this page, oh, here is all the bits you're going to want as soon as you get this. But I suppose it goes back to, don't just take the blob that would be sent over HTTP and put it in a bundle. It's just like your t-shirt says. I agree. BP does not equal IP. You can't just take an IP packet and store and forward it. It doesn't work. I think the same logic applies here of get Wireshark out, grab an HTTP request and stuff it in a bundle. I'm not sure is the smart thing to do. I think there's more we can do here than just encapsulate and shove it down a BP pipe.
So just to jump in on that certainly sounds like a much longer discussion.
Yeah, it is. That's my point.
Yes. Can we go on to the next, Stuart?
Short comment for Rick comment. I disagree. Let's talk on the mailing list.
Yeah, Stu here. So Mark, first off, thank you. I'm thrilled that you're doing both of these things, even if they are going to have, in some cases, unpleasant consequences that we're going to have to deal with. So I guess I'd just like to call the attention of the youngsters in the room to the fact that back in the day, we used to have dial-on-demand routers, right? And
Mhm.
branch offices that had a LAN and didn't have internet connectivity
Yeah.
would once a day dial into the corporate headquarters and make a UUCP connection.
Yeah,
We do-
UCB. Yeah, I was waiting
we-
to see you.
and we did stuff like this, right? That
Yep.
was how email moved, right?
Yep.
Email moved in a big bunch once a day in a period of like 20 minutes over a 4800 baud modem that you dial on demand, right? And there's still good ideas from those days that if you go back way, way back and look at old, email archives of IETF and so on. And so to Rick's point, I agree that we need to think about granularity and layers of abstraction. We may want to move something that is more abstract and at a conceptually higher layer than an individual HTTP request in some cases. And so that finally takes me back to your first consideration, which is don't do this with fancy web pages. Actually, you can do this with fancy web pages, but you don't let the endpoint parse the HTML and then make a boatload of requests. What you do instead is you put a proxy on each end. That proxy parses the HTML, gets all those pieces satisfied, builds a big honking bundle, and sends that. And I did it in 1993 and it worked just fine. So you can do it. Whether it is smart to do it is an entirely different question.
Good point, Stuart. In some ways, what you're describing can be done with what I'm describing, right? It's just, kind of pre-caching, kind of optimization, and, put everything in multiple bundles. So it's doable the way you describe. It's just a kind of a.
Sure.
I could probably add a paragraph or two about, those kinds of use cases.
Okay. Stephen?
Hi, Stephen Farrell. So I think this one is less crazy than the previous one. However, so I think in your picture you had a HTTP client. I mean, that has to be a modified HTTP client or it'll time out probably, right? And secondly, I think the challenge with this one is that we don't really use HTTP anymore. We use HTTPS.
Yeah.
And so I think unless you've got a good story there, and I don't know what it is, then it's really not going to be something that the typical application developer can use, because the web, the security model here is that your HTTPS is what application developers are used to. So there needs to be an origin. There needs to be some issues with certificates have to be thought of.
Mm-hmm.
So I think that would need solving, I think, before this would tend to succeed. But again, I think this makes something along these lines makes more sense than mail, I think, for transactional kind of HTTP applications.
So I agree with your point about HTTPS. Completely agree. Is on my to-do list. There's some text already, but on my local copy. Second, my comment about a developer thing was more far-reaching. Was more almost a joke. But what I was trying to convey is someone who is knowledgeable how to write modern HTTP application using REST APIs and JSON and stuff will be right at home with this proposal for developing, application that may go on long delay networks, with the only caveat that, be careful because the response may take more time than usual.
Yeah, I guess we're out of time, but I think that's kind of true, but also it's kind of not true, because for an average application developer developing some kind of transactional HTTPS application, they have a security model, and it doesn't match here. So that's a problem.
There's definitely a section on dealing with HTTPS properly. I agree.
The irony of saying this in a delay-tolerant networking working group is not lost on me, but we need to move on.
Sure.
So quickly, Joshua, if you have a quick comment, and then after that, a comment from Zahed.
Guys hear me?
Yes.
Okay. So my quick comment here is that I do like the general idea that we're bringing forth these things to be taken care of. I'm not sure I necessarily see the benefit of trying to standardize this specific concept because again, it kind of comes back to the what benefit do you get over just simply doing a giant IP wrapper instead of going all the way down to the HTTP. But it sounds like we really need a set list of application protocol convergence layers, more or less, is what we really are trying to poke at. But I feel like we, as Rick kind of mentioned, there are more things that we can take advantage of than just simply taking the protocol and slapping it into a bundle and running with it. There's a bunch of other things that really need to be done and probably standardized to really make the usability of these different application protocols correct.
Okay, just to jump in, we will interpret that as a +1 to open that discussion on the mailing list.
Yeah, provide text.
Okay, Zahid?
Zahid. First, without any idea on, I think, security is a big deal. When you're talking about application and all these things, we have these bundle security and all these things, but also like from an application perspective, we need to think about this. So that's like day zero kind of thinking. We cannot really wait on that. Like, okay, let's work on HTTP on next version or whatever. So that would be my comment. With Eddie hat on, I think this is great. This is great that we are talking about it. And this also gives me a feeling like, okay, we are perhaps in that state like, well, we have fixed the DTN networking. We know how to communicate. And now we're talking about application to run over it. That's simply a good thing. But I think I kind of agree with what people are saying. Like, this is, let's not focus on perhaps the protocol itself, like what protocol to run on application layer, what bundle protocol. But rather than what kind of application we're envisioning, what kind of like guidance or requirements we have, let's focus on those things and then create some requirement, then try to match this on the protocols that we have. I think that would be the right approach to handle it, rather than like, as you say, like when you came up with the SMTP, there are already work done. Maybe that's not the thing that we would like to hear. We'd like to hear like, we'd like to send an email like things over DTN network, what we should do. So focus, I would like to focus this working group on those kind of topics rather than a particular protocol right now. Thanks.
Thank you very much. Comment, thank you. The first thing I did before those two drafts is actually a draft that's called Application Framework, which is exactly, what you're describing and people were asking. But when I wrote it and sent it to the mailing list like a year ago, there was almost no interest whatsoever. And in London, I said, we should, if the working group is interested, I could resolve it. It's in the Internet Draft Depot. So, so that's exactly what you're describing.
Excellent. And we can discuss whether there was interest on the mailing list. Thank you very much. Our next presenter is Emery, who's going to talk about bundle protocol EID patterns.
You hear me?
Yes.
Excellent. So I'm giving this talk again on behalf of Brian Sipos. There is actually a draft RFC for this out there. The draft is entirely his, so I'm going to try and do it justice by describing what he's put forth and leave the questions up to him in the long term. Moving forward. So just a little background, right? We all know what the EIDs are. There's two today, the DTN, the IPNs. The idea here is that there's no standardized way to actually address them as a pattern or reference them via pattern. There are definitely implementations out there, but because there's no standard, that means there's not necessarily consensus against that patterning approach. There's definitely ways we can kind of cram this together, but that standardization allows us to effectively move forth and have a consensus to make this work. So I'm going to talk a little bit about both DTN and IPN here. Just a quick note on this slide, the IPN portion is in reference to the IPN update draft y'all heard earlier. So move to the next slide. So here are 4 use cases, and there's probably more, that sort of motivate why this patterning should be or could be useful. Number one, security identities. If we don't have a way to reference a group of EIDs, especially when you're looking at things like signing a certificate, something like that, and if it's not kind of standardized across the community, then that means there could be faults, and that's very bad with regards to security and signing of components. Another piece here is just like in CIDR notation, routing blocks. So how do you reference a group of nodes in a network or an entire administrative domain in the network? Definitely a need to pattern EIDs for that. Same thing for configuration of policy. So if you need to specify maybe who can operate on this node or who has authority to do something like in BPSec, maybe sign or validate some component. You need to be able to configure those. And then lastly, just in general, in talking in language, if someone refers to one of these EIDs, it would be nice to make sure we all agree to what we're each saying. So next slide. So this is the link to the latest RFC draft that is out there. It describes, like I said, both two parts, DTN scheme and the IPN scheme. So for the DTN scheme, the first thing to acknowledge is the need to separate those EIDs into both a node name and a service path segment. And then we can pattern based on either a literal match of those, a match of one part via a wildcard, a match of any parts, so i.e. the node name or the service path via wildcard, or even regex expressions or percent encoded means to look for patterns within each of those segments. For the IPN part, we're separating it into, you heard earlier, the three types, the authority numbers, the node number, and the service number, and then separating those into integer or single integer parts. So similar to DTN, now you can match on the exact value, match on a single wildcard, multi-wildcard, or a range of discrete values using those integers. One of the nice things here, this adds way to compress CBOR encoding for those integers, as well as allows kind of some more complex pattern matching. So move to the next slide and we'll get some examples here. So here on the left, you'll see examples for DTN. On the right, you'll see examples for IPN. The very first one, it looks fairly boring, but it's worth calling out that this pattern matching scheme actually allows you to match a singleton. So here, even though this looks exactly like a DTN or IPN scheme address, this could equally be a pattern. So it's able to go either way. For some of these others, right, for the second one, patterning all nodes on a service, you see how we've broken apart that first part, the DTN node name, but then the double asterisk or the wildcard for anything beyond that allows you to reference any of the services or any of that service path that's beyond that first portion. Same thing for the IPN scheme. A single wildcard allows you to reference any service at the end. Third one here, you see how there's two asterisks at the start. So effectively we're saying here is the service path, but anything that falls before that can be a pattern. Similar for IPN, anything that falls before that service of .5, whether it is an authority part or an authority plus node part, falls before that. Some of the complex wildcards, you can see there's actually now a combination. So maybe you know that there's a prefix in the middle of that DTN name, but you are unsure of the node name, you're unsure of the service, but you're looking for that component. Same thing applied to two different portions of IPN. The last two examples are definitely a little bit more complex, but shows you the ability to both pattern on a particular expression or range. In the IPN, right, you can create a sort of set of integer numbers, a range of integer numbers, and it allows you to filter on that address. Same thing for the mixed patterns, right? It's now a combo of both wildcards and range, or regex and wildcards. So just sort of a set of examples here to kind of walk through what Brian is effectively proposing in this spec. So next slide. So to drive a couple of things home, first and foremost, an EID pattern is not an EID. And there's a lot of good precedents for this in DNS names. And in fact, our RFC draft that's written goes into more detail about some of the security implications for this, but a pattern is not an EID. You would need something to reference and recognize that this is a pattern and use it to look up which EIDs might fall into that. It would never be used as an addressing scheme. EID pattern is a superset of EIDs. So that goes back to the point that the singleton matching pattern is itself. So this is nice and compliant in that regard. Let's see. So I think the last few things at the bottom right, just trying to call out what is the scope of some of these patterns specific to IPNs. So IPN 3.star.star is actually the same as 3.star, being that it includes a node number 3. Going against this new draft of the IPN scheme, this third example here, note that there is no star at the beginning, therefore there is no authority. So kind of going back to the conversation earlier of a 3 digit or three component piece of the IPN scheme, well, this one does not call that out, so it allows you to reference different either the authority type or the node type numbers here. You can see the next one actually does specify that you must have an authority, but it will only match that service 5 with that authority. And in the very last one, you can see it kind of will match both the authority number types and node number types, but only the service. So a little bit of flexibility in how you would pattern and how you would extract these things. But the purpose of this proposal is to kind of gauge interest across the community here to see what are your thoughts? Is something like this useful? And is this kind of the right thinking that would help patterning of EID names moving forward? So next slide. So exactly that, right? There's a draft document out there. You've got these slides here. Brian is easily accessible over the mailing list. I would say, what is the thought? Is there a need for this type of patterning? Should we standardize it in this form or in some other form? And I think the second bullet here is to, let's start experimenting with this. Let's put this into implementation and see if it actually works as expected. I think that was all the slides. So any questions?
We have one quick comment from Rick.
Yes, I really like the work. Emery, please feedback to Brian. And Brian, when you hear the recording, yeah, really like this. I think this is important. I think this may address some of Eric's comments to me about slash notation for numbering authorities. I will also reach out to Brian, review it in light of the IPN update, because some of the numbers don't quite line up anymore. But yeah, love it.
Right.
Excellent.
Thank you very much. We do have our last presenter. We will give you the full 13 minutes that we have left in the session.
Okay.
But please continue.
Okay,
Begin.
I will immediately get started. So hello everybody, I'm Sauli Kiviranta from Delta Signi Labs. Today we will go through introduction, why we are interested in the DTN work, and the little echoed discussion already today that on the application side we need more awareness of DTN work, and some best practices have been and will be very helpful for the developers. Then we go through findings, and hopefully at the end we have some time to discuss the future steps. So next slide. So our background is virtual and augmented reality, especially in the context of industrial services, working with automotive, energy, maritime, and medical industry and machine building industry. Please, next slide. And we started, or our background is on state research, dealing with machine building industry service operations. We have been involved also with the space industry service operations, as well as robotic services of, for example, ITER fusion reactor. Next slide, please. And one of the use cases we got from the space industry was support of the astronauts, the service operations of the International Space Station, and how we could use augmented reality to help the astronauts so that the engineers could assist in service operations. Please, next slide. As well as the clean room operations that have very much the same characteristics, that it's a place of assembly operations what are difficult to access by the other people who are involved in the design of the system. Next slide, please. And once we started to build our system, we thought that this is going to be walk in the park. We just grab WebRTC, slap a UI on top of it, and call it a day. But as you may expect, this was not exactly the case. Next slide, please. We go to the IT department and they say, no, that's not, guys, this is not going to happen. So shall not pass. Please, next slide. So here we were at the crossroads. So we knew that if you want to do real-time streaming, AR applications have the real-timeness of the video stream up and then the control stream down. But based on the circumstances, we just had to opt with the TCP and go forward that way. Next slide, please. So we didn't know if this is a good idea, but since we didn't have any options really, we wanted to proceed with the project. Let's do it anyway. Next slide, please. And at this moment, we were able to actually deliver our system. We were able to operate, and but we got some feedback from this is, for example, in this case, we were showcasing it at the ESA for the astronauts, and one of the astronaut trainers said that, guys, this is cool for the space context, but what we need the processes and technology fine-tuned on the ground segment. So please go with the traditional industry and let's figure out how to operate in the maritime, in the energy and other fields, and then bring it back to the space. And this was the moment where we realized that this type of a hardware system is not anymore scalable, and we had to go purely software side, and our product Pointer was born at this point. Next slide, please. And once we started to work with the traditional industry, we realized that actually security, for example, in terms of power plants and water purification plants and others, cannot be an afterthought. So this was already an advantage from our perspective once we had to use TCP. And the fact that what we had with the contractors in the clean rooms, that you have multiple, for example, military companies, that we had to be crossing multiple enterprise boundaries when we tried to transmit data between the sites. Next slide, please. And here we come to the context of the DTN, especially that we cannot assume connectivity. We cannot assume good channel stability, and we will be dealing with a lot of legacy systems also. So next slide, please. And the fact that disruptions and disturbances will be just a day-to-day case, it will be nominal. And this is also what we already discussed a bit, the message from me, that a lot more applications should be actually from the get-go adopting the best practices that the DTN working group will be providing. And also mentioned that offline mode, for example, in cargo vessels, there might be satellite connectivity on the deck. But once you are dealing with the engine rooms and other systems in the vessel, that you will be operating offline, and your applications have to be developed in the mindset of very much what bundle protocol is bringing into the picture, that sometimes you will be offline for some parts of the process. Next slide, please. And once we realized all this, we started to work with the European Space Agency on really figuring out the delay tolerance aspect of our system, as well as the disturbance tolerance in terms of packet loss and this situation where we are transitioning during the use of application to the offline mode and back and forth. Next slide, please. And after that project, we were much more confident. So previously, if you remember the system, we were able to deliver and it kind of did the job, but we absolutely were not ready for the space, for example, deployment to the International Space Station. But now we have much more confidence that it's not only that is it a good idea, but we actually see it working, and our approach brought some nice advantages along the way. So we have delay tolerance as well as the disruption tolerance. We ended up cooking our own internal bundle protocol equivalent, maybe much more primitive version of it, but the story and forward, especially in the offline context, is very important from the application development point of view. And the system design from extremes, especially if we are trying to be a spacefaring civilization, we have to start developing our application from the assumptions that there will not be good connectivity and there will be disturbances and delays. And also this continuous condition measurement is very important. If you go one slide back. And we ended up doing temporal and spatial bitrate adaptation for the video streaming. And we realized also that it's very important when you're dealing with DTN type of systems that you have to also communicate, remember to communicate to the end user that what is going on with the network currently for user experience. Next slide, please. So let's take a look at some measurements, what we have now done, what the system we built based on TCP, what we do today. Next slide, please. Here is an example in terms of packet loss. So that what type of a disruption tolerance we have been able to achieve. So on the left side, top left corner, you see a range of packet loss conditions starting from 0% going down to 10% packet loss. And most of this work, what we have done, is inspired by the people who are behind the LTP, the link leader protocol, and a lot of people in the DTN. And we can see that once we walk down the packet loss scenarios, we don't see dramatic increase in the delay, as well as when we are monitoring the output of the channel, we see that the retransmission rates are very much following the rate of our packet loss. And if we plot out these measurements into the graphs, we can see that the behavior of the transmission is very linear. So we don't see any exponential growth or runoffs on the transmission regarding the disruptions. And just for reference, what does it mean to be 10% packet loss? There is a very good measurement by Ulrich Spiegel on Starlink that it corresponds about using Starlink, for example, on a vessel during a storm. So this is related to critical infrastructure where regardless of the conditions, you still have to be able to communicate data. Next slide, please. Then we move to the delay resilience. Instead of walking down in terms of packet loss, now we are focusing on increasing the latencies. And for reference, for example, going around the Earth is about 200 milliseconds, communicating to ISS and background trip, it's about 500 milliseconds. Moon missions, about 1.2 to 5 seconds. And we can here do the same. We look at the average delay, and we see that it's roughly about a round trip. And the 99th percentile, since our packet loss in this test is 1%, it adds on one extra round trip of delay in context of TCP for the 99th percentile. And here in the graphs is something interesting. We see on the delay growth that it's very much linear all the time, and it's nice straight line. And on the output, we see some weird behavior. And this is maybe something that some experts from the DTN working groups might be interested in investigating. That about 800 milliseconds to 1000 milliseconds, we have a step change. Suddenly we have an extra 5% of retransmissions, which is abnormal. Based on the data, this shouldn't happen. So there's something weird going on with the maybe retransmission or this fast retransmission or something else. And the same step change we see at about 3000 milliseconds. Again, massive increase in retransmission. So this might be interesting to investigate for the delay resilience work. Next slide, please. So that was the technical side about the statistics and measurements. So let's quickly go through the future, what we could be doing. If you look at the real-time data transmission and streaming, there is a nice report by VOSA. There are already a handful of protocols that are capable of doing about 1 second latency. We have been able to, with TCP, push it to about 100 milliseconds. And this brings us to a completely new realm of possibilities, especially when we have some resilience on the packet loss side as well as on the latency. And the industry, about 14% of industry is capable of sub 1 second streaming, but 57% of them wants to go sub 1 second streaming. So let's take a look at 2 examples. Next slide. Here's an example of process monitoring and control. So you can imagine this comes from pulp and paper industry, that you have, let's say, multiple sites, about 100,000 sensors updating twice per second. That can be up to 1 gigabit of traffic. And with current technology, you can go to AVS and bring this up. You get about 700 milliseconds latency. But this type of applications are resilience and latency constrained, so that you cannot expect to utilize the same data to control the process back. You need the speed, and also for you to be able to remotely control industrial processes, you need to have the resilience what the DTN working group is bringing. And the next slide. And second example comes from the machine-assisted fleet control. In cargo handling, there are already many harbors that have this type of a concept, that there are hundreds of different cargo cranes, and the actual operators are not anymore sitting with the cargo cranes. They are actually sitting at the side of the harbor in an office, and most of the bulk operations of those devices are being autonomously handled. The devices are driving around, and once the actual work cycle of grabbing the cargo container, then the human operator takes over and performs this delicate act. And these applications are also resilience and latency constrained, that a lot of this work should be centralized so that they can serve smaller harbors, for example, in different cities. And this is simply not currently possible. So again, a lot of this working group advice and best practices are needed so that this type of application can scale more to the smaller deployments and handling multiple harbors from central place. Next slide, please. So this is a big market already. We see autonomous driving. They are also under the constraints, drone operations, maybe metaverse applications at some point, but smart factory and IoT. And our focus has been this industrial services and maintenance operations. So I think DTN is at the core of enabling this market. So word of encouragement to everybody who is working here. And also I would like to echo what was said by Mr. Blanchett, I believe earlier about this, that our application developments, it should not be a special case, but it should be rather the starting point that we develop our systems. And this way, we have more and more applications that are actually space operation compatible once we reach for the stars. Thank you very much.
Thank you. I know that we are 1 minute past, but and I appreciate your patience. We have one person in the queue currently. Rick, go ahead.
Thank you very much. A really nice presentation. Really, really interesting. There's some crossover here in what you're presenting between DTN and also what's happening in the IETF in deterministic networking, where a lot of work is going into ensuring that certain bounds on the characteristics you're getting out of the network are there, particularly for factory automation, particularly those remote examples you were using, AR/VR telepresence, a lot of the things here. And also the sub-branch of the deterministic networking group, the reliable and available wireless group, which looks at adding that layer of determinism across wireless bearers. So particularly disruption in terms of RF interruption, busy factory floors, and all that kind of remote automation stuff you've covered. So I suggest you also go and look at some of the deterministic groups as well as DTN, but great presentation.
Sure.
Thank you very much.
Thank you, sir.
And we have one more, Josh. We cannot hear you. Oh, we can hear you now.
Can you hear me now? Okay. Do you happen to have any more information that you can share with us regarding the delay resilience for LTP?
Yes.
Because I've been doing some testing in and of myself right around the 4-second delay range. And I'm seeing slightly different stuff. There is an exponential increase on when you start losing data. It does cause problems the higher the delay is for obvious reasons, because it just takes longer time to catch up. But if there's any extra information you can share regarding that, that would be amazing.
Yes, please feel free to reach out after. Unfortunately, you are not here, so I'm here for the rest of the day for people who are interested about those measurements. So I will be on the corridors, so we can just take a look, hands-on demo, and play around with the system to see how it works. But for you, since you're remotely, so feel free to please reach out for me, and I will be happy to share more information about that.
And please as well to share on the mailing list, because I know we have many people who have made similar observations. Thank you so much. We are just about 5 minutes past, but again, excellent working group meeting, and look forward to seeing everyone in 117. San Francisco.
Thank you all very much. Thanks, Ed. Cheers all. And I'm getting on a plane to San Francisco because I regret not making it to Japan. Have fun, everyone.
Give it a month. Give it a few months. Don't do that right now.
Yeah, don't come.
No, I'm going to go to San Francisco when everyone else is there, rather than just sort of independently. Not that there's anything wrong with San Francisco, but I want to see you guys rather than just wander around San Francisco. Anyway, I'm waffling. It's very late. The caffeine is worn off now. Good night.
Good night. Good night.
Good night. We did it.